The surgery that proved that there is no free will. This is interesting. Okay, let's see what's going on here.
Thanks for clicking on this video. But why did you click on this video? Not even 10 seconds ago, you were
because the thumbnail and the title.
mindlessly scrolling through your YouTube feed, and then you saw this title and thumbnail, and something in your brain had...
How did he read my mind? How did he read my mind? Before we start, do you guys believe in free will? Fundamentally, I don't. I believe in the experience of free will. I feel like I have free will, but like I don't think that fundamentally my choices are not predetermined. I think they are predetermined.
To know what it was about, so you clicked. But what was that something in your brain? Seriously, tell me, it might get my click rates up. But for real,
like for this, like my explanation of this would be like, yes, it's a catchy thumbnail, but I think that something in my evolution pulled me to click on the features of this thumbnail and like to be attracted to this. My experience of the world is very much based on my internal innate interests, and I don't think those interests are things that I have actively chosen. They're things that like I'm just naturally interested in. We are, as humans, just have natural interests, and they draw us to click on things that we're interested in and we want to learn more about. Our craving to learn is sort of, and what we learn is driven by our built-in interests.
We've got a motor cortex, a visual cortex, an auditory cortex, but where do decisions come from? That question got a lot more complicated in the 1960s when a new surgery started being performed on people with extreme epilepsy. It was called a corpus callosotomy or split brain surgery. Yeah, try to guess what they do. Yeah, they split the brain in half. Of course, the brain is already pretty much split in half between the left and right hemispheres, but they're connected at the bottom by a bundle of fibers called the corpus callosum. So yeah, they just kind of cut those fibers. This made it so the two halves of
Who's the first person to say like, fuck it, we'll just go for it. We're going to cut your brain in half. I think that's just going to make your problems go away. You'll be good. You'll be better off for it.
The brain couldn't communicate with each other, which sounds like it would be a huge problem. But believe it or not, they went on to live normal lives. This surgery didn't change people's personalities or ability to function, but there were some kind of weird things that came out of it. You know, things like their left hand would start drawing something and they didn't know why. It's like there was something in their right hemisphere that was trying to communicate. They were kind of like two different people in there. So if that's the case, the question becomes which one of those two entities are, you know, running things. The subject...
Are there multiple yous inside? Like if you have a left and right hemisphere and you cut it in half, do you think you're having two separate experiences? Because realistically, you wouldn't necessarily be able to know if you'd have two separate conscious experiences in your brain because you're not living both experiences. You would describe the other part of your brain doing things that you're not actively thinking about as just like your subconscious, but really it could just be conscious in itself and they're not communicating with each other at all. So it just seems like it's your like natural reaction to doing things, but it's actually something else that has a conscious inside of your own brain.
The split brain experiments has come out from time to time on this channel, but I don't think I've ever really done a full video on it. So I decided to do one because this topic is one of those things that just really caused this shift in like how I see the world, how I see other people, how I see myself. And it came from a book that I'll be sourcing quite a bit in this video, and I highly suggest you read it. It's called Who's in Charge by the neuroscientist Dr. Michael Gazzagana. Taking copious notes, as you can see. He did pioneering work on split brain patients in the 60s and 70s. He's written several books about it, done TED Talks. I'll link it all below. But the reason this book speaks to me, if I may, I don't know, get a little personal for a second, I've kind of always had this theory that there's different gnomes in my head. Obviously, I don't think that actual garden gnomes are living inside my skull. That's crazy. But like most people, I imagine, I do have kind of different voices in my head that have thoughts that bubble up from time to time, some of which I don't even agree with. Like, call it a defense mechanism, call it a rationalization of bad ideas or whatever, but that was kind of my way of explaining why I sometimes had conflicting ideas or had trouble making a decision, or like the negative thoughts that kind of take over sometimes. That's the negative gnome taking the wheel. Not much unlike the world that they created in the movie Inside Out, which I just saw for the first time fairly recently. And I've got to say, like, the way that they structure that world inside of her head to explain how memories work and emotions work, I thought it was brilliant.
Sometimes when I feel different emotions, I know that what I'm feeling in that moment isn't going to be how I'm going to be feeling in the next moment once that emotion has passed. I know that sometimes when I'm really angry and I have certain feelings and it's like, I'm super mad at the world, I know that the next version of me, like maybe in an hour or so when I cool down, is going to look back at that and say, okay, well, I mean, this guy was way too angry. It wasn't that deep. I feel like there's different versions of you and different states that you can be in where your thought process and what you think is and isn't acceptable changes, and what you think is and isn't wrong or going right changes. I can kind of relate what he's talking about.
Something else I liked about the movie was that the stakes were so small, but it still felt like a big thing. Like the climax of this movie is a little girl telling her parents that she's sad. And it carried more emotional weight than all these movies where like the world ending is at stake, Anyway, the point is that this book and the split brain experiments that he talks about in this book seem to make the argument that my little gnome's explanation for how my thoughts work isn't too far off the mark. And that free will and consciousness is just an illusion. There's a lot to unpack here. So maybe we could start by asking the obvious question, which is, why were they cutting people's brains in half again? Yeah,
that's a good question.
Sodomy, and they started doing it first.
There it is.
In the 40s as kind of a last resort treatment for severe epilepsy. Here's how it works. When you have a seizure, what happens is that there's a surge of electrical signal that disrupts the normal firing of neurons across the brain. Depending on where this occurs in the brain, you'll experience different symptoms. For example, an ocular seizure might give you a flash of light. But the worst, of course, are the ones that spread over the entire brain. These can lead to temporary paralysis and convulsions, vomiting, basically everything you think of when you hear the word seizure. And in people who get these multiple times a day to the point that they can't even function normally and no treatments seem to stop it, well, the best option is to just contain it. So the corpus callosotomy is done to prevent the signals from spreading to the entire brain, so it stays in whatever hemisphere it started in. Kind of like a surge protector.
Wait, so you still have a seizure, but it's just the one side of your brain, so it's not as intense, and you might have still some control over what's going on.
The first corpus callosotomy was done in 1936 by a neurosurgeon named Walter Dandy. Kind of an accident. He was removing a tumor on a patient's pineal gland, and it required him to cut through the corpus callosum to get to it. He reported that this had no real effect on his patient, which there had been a debate for a long time about what the corpus callosum was actually for. Like, was it actually involved in processing, or was it just structural, just kind of there to hold the brain together? The result of this experiment seemed to suggest the latter. Regardless, in 1940, William P. Van Wagenen decided to try a corpus callosotomy on an epilepsy patient, and he saw mixed results at first, but they were promising enough to continue experimenting with it. By the way, this is all starting to sound kind of familiar. All of this happened about the same time as the lobotomies, which I covered fairly recently. This was basically the period of neuroscience when they started paying attention to the white matter fibers and cutting connections just to see what would happen. I should be clear though, while lobotomies were being handed out like candy, split brain surgeries were much more extreme and pretty controversial at the time, actually. This was only for people with a very specific, very debilitating condition, and even then it was only a last resort. It really wasn't until the 60s when two neuroscientists named Joseph Bogan and Philip Vogel kind of perfected the procedure, and it became thought of as an effective, safe treatment. But not without a few weird side effects. Like sometimes they had trouble getting their two hands to work together. One patient talked about how he had trouble buttoning his shirt because he'd be buttoning it up with one hand, and then his other hand would go behind it and unbutton everything that he had just buttoned. And stories like this just kept coming up, like patients whose hands would just grab things for no reason or would mess with the other hand, to the point that Joseph...
That'd be a good excuse, like if you like slap somebody and you're like, that was the right side of my brain. I swear to God, I didn't do that on purpose.
Probably somebody should research this. Luckily, he knew just the perfect person to do this, a neuropsychologist named Roger Sperry. Roger Sperry was born and raised in Hartford, Connecticut, and went to Oberlin College on a scholarship where he originally wanted to major in...
You know he's smart because those eyebrows.
...the intro to psychology class that sparked an interest in psychology. Yeah, the story goes that apparently his professor was disabled, so Roger Sperry kind of helped him to get around and took him to various places and stuff. So he wound up kind of sitting in on conversations that this professor was having with his colleagues, talking about their research, debating different psychological theories and whatnot, and he just got sucked into it. He just found it fascinating. So he got his master's degree in psychology and later a PhD from the University of Chicago, and then he went into his career. He became more interested in neuronal specificity and brain circuitry. Basically, like how different parts of the brain work and how they're connected. He did experiments on rats and salamanders that involved kind of rewiring their nerves, like in their legs and their eyes, to see if they could adjust. Spoiler alert, they couldn't. But through all of his research, he kind of became known as an expert in how different parts of the brain work and how they talk to each other. So, of course, Bogan thought that he would be just the right guy to study split brain patients. And, of course, Sperry took him up on it because what an amazing opportunity. He did also do some...
Do you think that it's just not so immoral to do experiments on rats like that? There's so many experiments we've done in history on rats and animals, chimpanzees, abusing them and totally using their bodies for science just so we can figure out something about how our brains work or how a virus may work on us. We killed so many of these rats just to figure out something for science. While it's been very interesting, like the findings we've been able to have, like, is that not so crazy that we did that we do that?
Some experiments on animals before he went into his human research. I know none of us like to hear about animal experiments, but he did do some corpus callosotomies on some cats and tested them. Luckily, he didn't have to do the surgery on the split brain patients because, well, that had already been done. So Sperry found a group of Bogan's patients that were willing to volunteer for his tests, which focus on vision, language, and motor skills. This would involve showing words or images to the left or right visual fields to see how the different hemispheres handled it. This requires some explanation. As you may already know, the hemispheres are what they call contralateral, meaning the left hemisphere controls the right side of the body and the right hemisphere controls the left side of the body. Also known by its technical term, crisscross applesauce.
It just looks like a guy with really bushy eyebrows.
But your eyes are a little bit weirder. It's not quite as simple as just each eye goes to the opposite hemisphere. They go to both hemispheres at the same time. What happens is the two optic nerves converge at a spot known as the optic chiasm, and there they split apart, with one split carrying the left visual field and the other one carrying the right visual field. And then the left visual field from both eyes gets sent to the right hemisphere, and the right visual field from both eyes gets sent to the left hemisphere. So it's still contralateral, but with extra steps. So if you're staring at my face right now, Zoe is in your right visual field. You're seeing her blessing you with both eyes, but it's the left side of the brain that's processing that image. Your right hemisphere literally can't see Zoe right now, but it knows she's there because the left side's sharing that information through the corpus callosum. But what if you don't have a corpus callosum? This is what Roger Sperry wanted to figure out. So he came up with a series of tests along with his graduate student, Michael Gazagna, the guy who wrote this book. Sorry, I just have to clarify one more thing before I get into the results of that test. A lot of the basic functioning of the body takes place in what's called the subcortical region. This is an area that's actually shared by both hemispheres of the brain. This includes structures like the thalamus, the hippocampus, the amygdala, and a lot of other things that you probably never heard of. But these kind of handle the basic stuff like motor control, sensory processing, something they call proprioceptive sense, which is basically our sense of our body's position in space. So that's handled before everything gets split up. There's no one hemisphere that controls that. This also includes what Dr. Gazagna calls an integrated spatial attention system, which is basically something that directs where the brain pays attention to things. So it's not like you could be doing homework with...
Just hearing all this stuff being explained about the human brain just makes me feel so uncomfortable sometimes. Just thinking about, man, this is so fragile. What if something stops working? Like, there's so many moving parts, and just think about a computer. And it has so many moving parts and stuff goes wrong all the time. Why does our brain keep working for like 80 years nonstop? And how is it able to just be so resilient, even though it seems so fragile?
One side of your brain and gaming with the other side of the brain. That'd be nice, though. Anyway, I know that was a lot of exposition, but it's just all stuff you kind of need to know before we get into the good stuff. So here comes the good stuff. So one of the first patients that they studied was a man named WJ. They kept their names anonymous for obvious reasons. WJ's test started out pretty simple. They showed him pictures and words in a right visual field, and then he was able to respond with his left hemisphere. A dog, a car, a spoon, easy. Easy because the language center is on the left side of your brain. But when they showed an image in his left visual field that went to his right side of the brain, he claimed that there was nothing there. Now, this was a really big moment because up to this point, there was still a bit of a debate around how much the corpus callosum controlled the flow of information between the two hemispheres. And this seemed to be indisputable proof because it wasn't that the right hemisphere couldn't see the object. It could see it just fine. It's that the language center of the brain is in the left hemisphere. So it literally didn't have the words to describe it. So based off of this, they tried a new experiment, this time with a basic flashing light. So what they did was they put his hands under a barrier so his eyes couldn't see his hands. And he gave each hand a button. And he told him whenever he saw a flash of light to click the button and then confirm it verbally by saying light. So they signaled his left hemisphere. He clicked the button. He said light. Then they signaled his right hemisphere. He clicked the button and then said, hey, why did I click that button? He didn't see
Oh, wow.
but the right hemisphere did. And it was able to communicate that it did. It just couldn't do it with language. It's kind of like the left hemisphere has a voice and the right doesn't. But now they were...
That's crazy. So your different hemispheres are responding for themselves what they're seeing, but they're not communicating with each other. So your experience of it is skewed. You're experiencing two different things. But is it even you, or is it like two different versions of you experiencing different things in different ways? Are you even just one person inside of your head, or are you just multiple people, multiple different systems just working together and trying to communicate with each other?
Figuring out how to talk to the right hemisphere. And now things get a lot more interesting. These kind of results bore themselves out over and over and over again with other split brain patients as well. Like in one experiment, the left hand was placed in a box with a handful of objects in it. And then they flashed an image of the object in the right hemisphere, and the left hand was able to feel around and pick out the right object. When they asked the patient why he grabbed that object, of course, he had no idea. And sometimes the patient could just draw the image. For example, they flashed an image of a bike at the right hemisphere of one patient, and then his left hand drew a bike. But think about the experience that the patient is having. He's just sitting there, he's got a pencil in his left hand, and he's waiting for them to flash an image at him. And he's waiting. And then his left hand just draws a bike. These experiments would progress and become more complex over time, and they began to understand just how different their left and right brains really are. You know how we always talk about left brain people being analytical and right brain people being more creative, that whole thing? Well, here's how the two hemispheres are actually different. Basically, the right hemisphere was better with visual and spatial skills, and the left hemisphere was good with language. Like he described an experiment where the patient was flashed a picture of a pattern of colored blocks, and then he had to recreate it. And when they flashed the right hemisphere, the left hand was able to recreate it really easily. So the right hemisphere was really good at that.
My question is it possible to just function with one hemisphere at all? Like, if one's better at certain things than the other, does that mean that each one still has all the skills to some degree, but one is just, less and one is just more at certain skills? Like, could you theoretically function with one half of your brain if you were able to do the surgery in a perfect way?
But when they did that with the left brain, the right hand it really struggled with it. In fact, there's one story of a patient who was struggling to put it together with his right hand, and his left hand kept trying to help. He had to actually sit on his left hand to keep it from trying to help the right hand out to solve the problem. According to Dr. Gazagina, quote, the right hemisphere turned out to be specialized for such tasks as recognizing upright faces, focusing attention, and making perceptual distinctions. The left hemisphere was the intellectual. It specialized in language, speech, and intelligent behavior. There were also differences in logic and problem solving between the hemispheres. Like, they'd show the right hemisphere a picture of water, and the guy would point to a picture of water. Then they show the picture of a pan, and the guy would point to a picture of a pan. But when they asked what they could do with those two items, the right hemisphere just couldn't quite figure that out. Whereas the left hemisphere knew right away that you put the water in the pan. The right hemisphere also struggled to come up with inferences. Like, in another experiment, they showed a picture...
Who puts water in a pan?
Picture of a match, and then a picture of a wood pile, and they couldn't quite figure out that the next image in that series should be a burning wood pile. And in another experiment, the patient was shown the letter U and asked to turn it into a square using a choice of shapes, and the right brain couldn't do it, but the left brain had no problem. Like, the right brain is very literal. Things just are what they are. He uses the example of a box of candy. So, like, if somebody gave you a box of candy, your right brain would just be like, yes, that is a box of candy. But your left brain will try to figure out why they gave you a box of candy. What this means is that both halves of the brain are experiencing consciousness, but very different kinds of consciousness. As Dr. Gazagina puts it, quote, it was becoming apparent that the right hemisphere had its own rich mental life, quite different from that of the left. So right away, we can see that there's not just one
consciousness. That's so weird. Oh my God. This is breaking my brain. It's like literally, no pun intended, but it's like I'm having this singular experience. It feels like a singular experience, but there's so many different things going on in my brain. And you're not necessarily experiencing every single thing going on in your brain. You're just doing what you do. and then you're feeling like you chose to do everything that you do, but really there's things going on in your brain that are dictating what you're doing that you have really no conscious experience of, in this like singular free will illusion that we have
going on inside our minds. There's two, but it actually gets crazier. Turns out it's actually multiple modules inside each of the hemispheres that can display a kind of consciousness, and they have their own things to say. So you remember earlier when I was talking about trying to imagine what it must be like for these split brain patients when their left hand just kind of randomly does something beyond their control, how weird that must be. Well, Sperry and Gazagana were wondering the same thing. So they began developing tests to see how patients explain these actions. Like the left brain normally has a gigabit internet connection with the right. They're sharing everything. But now it can only get information from seeing what the brain does externally, from the pictures that it points to and the words that it writes and whatnot. And if the left brain is more interpretive and wired to find patterns, what would it interpret from that? Turns out a lot. So in one experiment, a patient was shown a chicken claw to his left hemisphere and a snow scene to his right. He was then asked to choose a picture that related to what he was shown. So his right hand pointed to a picture of a chicken, which obviously makes sense because the guy saw a chicken foot, but then his left hand pointed to a shovel, which makes sense because his original picture was a snow scene. But he didn't consciously see the snow scene. So when they asked him why he selected that shovel, he said, quote, "Oh, that's simple. The chicken claw goes with the chicken, and you need a shovel to clean out the chicken shed." The left hemisphere,
my God,
without hesitation, came up with a justification for what the right hemisphere chose. It didn't say, "I don't know," which would have been the correct answer. It didn't say, "Oh, maybe it's this, I'm just guessing." No, it confidently declared chicken poop. And this was a result.
Oh my God. So it's you're like half of your brain is just watching what your other half of your brain is doing and interpreting it without just through the visual perception. You're not able to communicate directly like the reason why. You're just having to like watch your partner, your co-pilot, do something and try to like come up with an explanation for it. That's crazy.
That repeated itself over and over and over again. In another example, the word music was flashed to the left brain and a photo of a bell was flashed at the right brain. He was then given several images to choose from. These images were all musical instruments, by the way, including the bell. So the patient acknowledged that he'd read the word music with his speaking left brain, and then his left hand, controlled by his right brain, picked the bell image. When asked why he picked the bell over all the other musical instruments, the patient said, quote, "Well, the last time I heard any music was the bells banging outside here. There was a church across the street." Again, the left brain, having absolutely no idea that the right brain had seen a bell, confidently came up with a justification. One more example of this was an experiment where they flashed the word red to his left hemisphere and the image of a banana to his right.
That's crazy. So like that just goes to show that your reasons you think why you do something, like if somebody asks you why you did something, you'll come up with a reason for them to give them. And I feel like a lot of times that reason is something you just fabricated because you don't actually know the reason why. Like you don't necessarily know every reason for why you do something. There's things going on inside your brain that you have no control over that lead you to do and think the things that you think, regardless of your active input into active like reasoning behind it, if that makes sense.
Hemisphere. He was then asked to draw a picture with his left hand out of an assortment of different colored pencils, so he picked the red pencil and he drew a banana. But when they asked him why he drew a banana, he said, quote, "It was the easiest to draw with his hand because this hand can pull down easier." Which, by the way, makes absolutely no sense, but that's what the interpreter came up with. And this was the name that they gave it, by the way. They call it the interpreter module. They also found the interpreter module hard at work explaining emotional triggers. So, for example, in one experiment, they showed the right hemisphere a scene from a fire safety video where a guy gets pushed into a fire, and the patient just reported that she only saw a white flash, but then afterwards she noticed a change in her mood. She said, quote, "I don't really know why, but I'm kind of scared. I feel jumpy. I think maybe I don't like this room, or maybe it's you. You're getting me nervous." In another experiment with
like when people walk into a room and they feel like that there's a bad vibe to the room, there could be things that they're getting input from that they have no like active awareness that they're getting those inputs that alter their mood.
The female patient, they flashed the picture of a pinup girl to her right hemisphere, and then, without knowing why, she kind of snickered a little. And when they asked her why she was laughing, she said that they had a funny machine. Like, have you ever had a random mood change? Like, suddenly you just get angry or sad, and you don't know why? There's stuff going on in there. And in case you haven't noticed, in every single one of these examples,
I feel like, okay, so I've done like psychedelics before, like shrooms before, and when you're on that, your mood can change pretty quickly based on just a very singular input. And I feel like it teaches you a lot about how your brain works. That's why your setting to be so controlled when you're doing that, because like certain things can trigger you very easily. And I think that in that state, you realize that your mind can just take on a life of its own, just from one like picture that's scary. It can make you feel really bad in that state, and make you start to panic and things like that. So I think it's interesting how the brain can just, different parts of the brain can just use different things and alter the entire mood of the entire brain without necessarily giving a good reason for why it's doing that.
the interpreter module was wrong. Often confidently wrong. It got limited amount of information and assumed it knew everything about it. Might as well call it the Dunning-Kruger module. And yet, this module is kind of running the brain, or at least navigating our thoughts. Its further testing revealed that the interpreter module is just one of multiple modules in the brain, all of them kind of black boxes. Like, we don't really know how they make their choices, but they make choices, and then the interpreter module justifies it. Like, for example, fMRI tests showed that different areas of the brain would light up before a conscious decision was made to, say, take an action or to say something. That was a decision being made before the decision was made. This is basically how we live our lives, just walking around justifying the decisions and thoughts that pop into our heads from various random semi-conscious modules in our skull. This fact has been such a revelation for me because I don't really think of my thoughts and my actions as me doing it anymore. You know, I mean, yes, it's me. I'll get to the theory of mind around it in just a second, but it's a lot easier to look at your thoughts and beliefs objectively if you don't think of it as being part of you. Like, when I have a thought that comes...
That's why it's so hard to change certain habits of yours, because like there's so many underlying things that your brain is doing to get you to do something over and over again, other than your like secondary meta understanding of what's going on and like meta decision making. You can have a craving to eat junk food, and you know, you have certain parts of your brain that are telling you, oh, I need these calories right now. I need this flavor. I need to get that into my stomach immediately. But it takes so much effort to override that secondarily, even though you feel like you can just make every single decision and life is just a bunch of decisions. There's other decisions being made in your brain. It just makes so much sense that there's all these different parts of your brain competing for this decision to be made.
I don't know where it came from, so I can just ignore it if I don't like it. It's not tied into my sense of self. My ideas aren't my identity. And it's a lot easier to change your mind on something if you don't have it tied to your identity. Also, once I understood that our brains are just constantly justifying things, just justification machines, basically, I find myself often just kind of pausing and asking myself, like, what am I justifying right now? It's usually when I'm procrastinating on work. Like, here's a crazy thing that we do. Have you ever noticed, like, that you felt anger or annoyance at someone after you've hurt them in some way? We've all done it. We hurt people's feelings. We failed to live up to a promise, betrayed someone. It happens. That's life. But there's a psychological phenomenon that happens where, like, we know we hurt someone and we feel bad about it, but then that justification module kicks in and just sees that, you feel bad and it has something to do with that guy. Well, that guy must have done something wrong. And then you wind up feeling resentment toward the person that you hurt, which is crazy, but we all do it. We are constantly justifying bad behavior and bad habits in the service of comfort or protection or just a dopamine hit. That's normal. It makes us human. But the awareness of it can kind of change your life. But the other mind-blowing part of it gets into questions of free will. Like, what is actually controlling our decisions? There are some that make the argument that this disproves free will, that our decisions are made by patterns of neurons firing in a predetermined manner, that we're not even consciously aware of our decisions at all. These guys call themselves determinists. Taken to an extreme, one might make the argument that nobody can be held accountable for their actions at all because they weren't the one.
When it comes to free will and people committing crimes, I think we still need to, hold them accountable for their decisions, whether or not those decisions are fundamentally alterable by them. I think we still need to hold people accountable just to create like a safer society. We don't want to give these decision-making processes inside our head the blank check to do whatever you want. Having certain barriers to committing crimes is important for deterring those decision-making processes, whether it's you able to make that final decision or if something else in your brain forced you to do it. Whatever, on whatever level, it's still effective to have deterrence for people making those decisions. So I don't think that not believing in free will automatically justifies all crime or something like that. Or I don't even think it's about justifying crime. I think it's the justice system should be more so about trying to create a safer society rather than thinking of blaming individuals for doing things and like punishing them. I think to me the justice system is more about creating a safer society. But a lot of people think of it as like, oh, this person needs justice. They need to feel the pain of what they did. They need to like, I think you're thinking of it the wrong way around. I think you need to be like, how can we make society safer, make sure that these things don't happen again in the future? We need to have deterrence for that. That's fascinating to dissect the brain and really learn about why we do what we do. There's a lot more going on in there than you would think. I'll catch you guys on the next video.